All right, so for number 40, part A, so it says identify the value and location of any relative maxima or minima of the following functions. So when it comes to maxima, that is where our function is increasing and it hits a high before decreasing again, right? So if we take a look at this graph, we see that it comes up here and hits a high before decreasing again, and then it does it again over here before decreasing again. And so if we write that out, we say relative maxima. And so let's see, what value does it hit? It hits 5 at x equals -3 and hits 5 again at x equals 3. And so we can just say 5 at x equals -3 and 5 at x equals 3. Now for the relative minima, I'll write that out real quick. So it's like the opposite, right? It's where the function takes a dip, where it's like decreasing, and it takes a dip at the lowest point before increasing again. And so if we take a look at this graph, it looks like it's decreasing here, and it dips, takes a low right here before increasing again. And so we can say the relative minima, let's see, it hits 0 at x equals 0, right? So we can just say 0 at x equals 0. All right. So if we go to part B and apply that same principle for our, I'll just say relative max this time. So what does it look like? Well, it looks like it's increasing and it hits right here, right, before decreasing again. And so our relative max is at the point 2 at, and then x equals 0 at that point, right? And so then if we look at the minima, it looks like, so it's decreasing down here and hits a low before increasing again. And then kind of same over here, it does like the same pattern where it decreases, hits a low before increasing again. And so it looks like the relative min is, well, all right, so on both of them, it looks like the minimum value, or the y value, is at 0. So I'll just say 0. And so for the first one, it's at x equals -2. And for the second one, it's at x equals 2. All right, so for -41, it asks to use interval notation to write the intervals over which the following functions are increasing, decreasing, or constant. All right, so let's see, for part A, we'll have it's increasing, and I'll just say A right here. We're going to be stretching the room on this, but we'll have increasing, decreasing, and constant. All right. So if we look at where it's increasing, or where the y values are getting bigger while the x values are getting bigger, it looks like it's going up, 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 until it hits this point, right? So we know it's going to be increasing from -infinity to what x value is at? That's at -3. And then let's see, it looks like it starts increasing again right here, right, where it's going up as the x values are getting bigger. And so we can say from 0 to, let's see, it stops increasing at x is equal to 3. So that'll be our increasing interval. Now if we look at decreasing, so we'll see that after it increases here, the y values start getting smaller as the x values are getting larger. So it's decreasing on that interval. That's going to be from -3 to, looks like 0, right? And then it looks like whenever we stop increasing here at x equals 3, the y values start getting smaller as the x values are getting larger. And so we know that it's decreasing from that x equals 3 all the way to when x equals infinity. And it's constant? Never. There is never a point where the y values are the same with the x values in series. All right, so then if we go to part B, we're going to have increasing, decreasing, and constant. All right, so if we look, it looks like it's increasing. It's getting bigger from -2 until it hits x equals 0. So we can say -2 to 0. And then it looks like, again, it from 2, x equals 2, to infinity, looks like it's increasing, right? If we're going from left to right. So we can say union from 2 to infinity. Now, when it's decreasing, it looks like, so when it's coming from negative infinity, it's the y values are getting smaller and smaller and smaller until it hits -2, right? And then it starts increasing again, like we said. So it looks like it's decreasing from negative infinity to -2. And then it looks like once we increase from that -2 to 0, it looks like it takes a high and then starts decreasing again. And so it decreases from 0 to 2. And it's constant, never. All right? So then if we go to part C, I'll write part C over here. We'll do increasing, decreasing, and constant. All right, so it looks like it's increasing. If we're going from left to right, the y values are getting bigger from negative infinity until we hit 0, right? So we can say from negative infinity until we hit 0 for the x value. Now, it looks like it's decreasing, so once it hits x equals 0, it looks like it's decreasing on this little stretch, right? And so that would be from 0 to 1, right? So it hits this point. So I'll say from 0 to 1. And then it looks like it becomes constant, right? And so from here to, looks like x is 4, it's a constant y value. And so it'll be constant from 1 to 4. All right, so for number 42, we are given some functions and some operations are being performed on them, and so we have to find them and simplify them. So for part A, this says f plus g of x. So that equates to f of x plus g of x, right? So we're just adding their functions. So that's going to be, our f of x is x squared minus 5x plus 3, 5. And that's going to be added to our 2x minus 1. All right, so if we combine like terms, we can add the 5, the negative 5x, and the 2x, and then the 3 and the negative 1, right? And so that's going to give us x squared minus 3x plus 2. All right, so then if we move on to part B, it says g minus f of x. So that is going to be g of x minus f of x, right? So then we'll have this 2x minus 1 as our g of x. And that's going to be minus this whole thing of x squared minus 5x plus 3. That whole thing is going to be applied there. And so then we can distribute this negative. We have to actually distribute this negative to all three terms. So to the x squared, to the negative 5x, and to the 3. So then that's going to simplify to 2x minus 1 minus x squared plus 5x minus 3. All right, so then if we combine like terms there, that's going to be negative x squared plus 7x. Oh my goodness. Okay. I'm going to write this down here. Negative x squared plus 7x minus 4. All right, so for part C, it asks for f times g of x. So we know that that's going to be f of x multiplied by g of x. So that's going to give us x squared minus 5x plus 3 times 2x minus 1. All right, so then if we kind of multiply these terms out, we're going to get x squared times 2x, then x squared times negative 1, then negative 5x times 2x, then negative 5x times negative 1, and then 3 times 2x, and then 3 times negative 1. And so if we do all of those operations, our x squared times 2x is going to give us 2x cubed, and then x squared times negative 1, that's going to be negative x squared. Then negative 5x times 2x is going to be negative 10x, and then negative 5x times negative 1 is going to be plus 5x. Then if we do 3 times 2x, it's going to be plus 6x, and then that last term, 3 times negative 1, is going to be negative 3. So then if we combine all of our like terms, we'll have, let's see, we'll have the negative x squared and the negative 10x, and then we will also have 5x and 6x. So if we combine all of those, we'll get 2x cubed minus 11x squared plus 11x minus 3. Alright, so part D on g over h of x, so that's going to be, and I'm just going to kind of bring it over here so you guys can see them right now on the left, but that's going to be g of x over h of x, right? So then we just take those functions and divide them. So that's going to be 2x minus 1 over all of h. So that's going to be 3 plus the absolute value of 2x minus 1. Absolute value close. Alright, so on part E of g plus h of negative 5, we know that that's going to be equal to g of negative 5 plus h of negative 5, which is going to give us 2 times negative 5 minus 1 plus 3 plus the absolute value of 2 times negative 5 minus 1 equals absolute value. And so that's going to leave us with, we'll have 2 times negative 5, so negative 10 minus 1 plus 3. And then in the absolute value, that's negative 10 minus 1, which would be a negative 11, right? But instead it's going to be a plus 11 because of the absolute value making it positive. And so then if we add all of those terms together, we should get 3. So on part F, it's asking for f over g of 3. So that's going to be f of 3 over g of 3, which is going to be 3 squared minus 5 times 3 plus 3 over 2 times 3 minus 1. And so then if we perform those operations, we should get a negative 3/5. Alright, so for number 43, it says find the difference quotient and simplify for the following functions. Alright, so I'm gonna do this over here because I know we'll need a lot of work for it. So we have this difference quotient function, right? And so we can use that to simplify the difference quotient. So then we'll have f of x plus h. So what that's doing is that's taking every x term that we have and just doing, instead of it being x, it's going to be x plus h. So instead of us having negative 3 times x, it's going to be negative 3 times x plus h. And then we'll still have our positive 5, so plus 5, and then minus that whole f of x function. And so that's going to be minus our whole our whole negative 3 plus 5. And that's going to all be over h, right? So then I can, distribute the negative 3 to the x, the negative 3 to the h, and then distribute this negative to the negative 3 and to the 5. And so then if I do that, I'll get negative 3x minus 3h plus 5, and then plus 3x minus 5 all over h. So then we can combine like terms, right? So we have these 3x's that cancel out, And then we have these 5, they cancel out. And so then we're just left with negative 3 over h. No, sorry, negative 3h over h, my bad. And whenever something divides by itself, that's just going to be 1, right? So we got the h's that cancel as well. And so that just leaves us with negative 3. So I'll write that over here, negative 3. All right, so for part B, we have this one, and it's a little bit more complicated, but I think we can do it. So if we do f of x plus h for this function right here, and I'm going to write this kind of over here. So that's going to be 2 times, so instead of x, it's going to be x plus h squared minus 5 times x plus h plus 3, and then minus our whole f of x function again, so it's going to be minus the entirety of 2x squared minus 5x plus 3, and that's all going to be over h. So then we can start simplifying, and so this x, and okay, so I'm just going to take this term. Let's look at this really quick. So we have, and I'm not going to do that right there. Let's bring it over here. So x plus h squared is not the same as x squared plus h squared. We know that that's going to be equal to x plus h times x plus h. And so if we do that, if we do those operations, we got to distribute the x to the x to the h, and then this h to the x, and then this h to the h. So if we do that, that's going to give us x squared plus 2xh plus h squared. And so then we can go ahead and plug that back into our difference quotient. So that's going to be 2 times x squared plus 2xh plus h squared minus the 5 times x plus h plus 3. And then I'm just going to go ahead and distribute this negative up at the top, this negative to all those terms. And so then that's going to be, not equals, it's going to be minus 2x squared plus 5x minus 3 over h. Man, we never have enough room on these. Okay, so then I can distribute the coefficients, so I can do the 2 to all of these terms, and then the negative 5 to both of his terms. And then that's going to be, so that's going to be 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 3, and then minus 2x squared plus 5x plus, minus 3 all over h. So then if we combine like terms, this should make the fraction a little bit smaller. So then we got the 2x squareds that are going to cancel over here. And then we have the 5x's that are going to cancel. And also the 3's that are going to cancel, right? And so then, let's see. So then we're just left with 4xh plus 2h squared minus 5h over h. Now, notice that all of these terms have an h with it, right? So we can factor an h out. And so if we factor an h out of all of that, that's going to be h times 4x plus 2h, and then minus 5 all over h. And so then the h's cancel, right? Which is perfect, and just leaves us with 4x plus 2h minus 5 after all is said and done. All right, so for part C, and also I'm gonna go back to part B a little bit here, and I'm just gonna write that up here so you guys can see. That's gonna be 4x plus 2h minus 5. That's our final answer. So then for part C, let's see. If we set that up and I'm going to write this back on the left side. So that's going to be 3 over, that's going to be x plus h, right, instead of x, plus 2, minus our whole f of x function, which is just minus 3 over x plus 2, and that's all going to be over h. Now, whenever we have x's in the denominator, that's a little bit tricky, right? Because it's not as easy to simplify. But what we can do here is find a common denominator. So this denominator is x plus h plus 2, and this denominator is x plus 2. So we can just combine those and make a common denominator of, and I'll write this down here too, make a common denominator of x plus h plus 2 times x plus 2. And so then, if we do that, that means we're going to have to multiply this side times x plus 2 and multiply this side by x plus h plus 2. So then if we do that, for this first part, that's going to be 3x, and I'm just going to distribute that, plus 6, and then minus, remember, this whole thing of, let's see, so if I distribute that, that's going to be 3x, and then plus 3h, and then lastly, plus 6. And remember, this is all still going to be over h, right? So then I can distribute that negative, right? So that's going to be 3x plus 6 minus 3x minus 3h and minus 6 all over our common denominator of x plus h plus 2 times x plus 2, and then all over h again. So then let's cancel out some terms here. So that's going to be the 3x's are going to cancel, the 6's are going to cancel, and so then we're just left with negative 3h. And what we can do is, since this is all over h, we can just bring the h to the denominator here, because it'd be like, if you remember multiplying or dividing fractions, if we have fractions over each other, we can treat this as like h over 1 and, perform the skip, flip, multiply. So that's going to equal negative 3h over h times x plus h plus 2 times x plus 2. And so then we see that h is canceled. And so then we're just left with negative 3 over x plus h plus 2 times x plus 2. And so I'm going to write that up here. That's going to be our final answer, is negative 3 over x plus h plus 2 times x plus 2. All right, so for number 44, looks like we have some function compositions, right? So we're given two functions, f of x and g of x, and we have to find, okay, so for part A, we're finding g of f of x. Okay, so for these kind of problems, what we're doing is we're taking this function and putting it, or I guess the right function, and then putting it into all the x values of the left function. And so what that means in this case is we're going to take this f of x and we're going to put it in all of the x terms of our g of x function. And so it looks like we only have one x term, right? So then that's going to be 2 times the whole function, 3x squared minus 7x plus 2. And then we still got that plus 5 tacked on the end, right? Oh, my bad. Fix that really quick. Plus 5. And so then it looks like if we simplify that, if we distribute the 2 to that, the 2 to the negative 7, and the 2 to the 2, then add that 5 at the end, that's going to be 6x squared minus 14x plus 9. All right, so for part B, it's going to be a little bit more complicated, but we can still do it. So we got f of g of x, and so what we're doing now is we're taking g and that whole function of g and putting it in for all of the x terms in the f of x. And so it looks like we have 2 x terms in this f of x function, right? So then our f of g of x is going to turn into 3 times the entire function of g, so 2x plus 5, and that's being squared, minus 7 times g of x again, 2x plus 5 plus 2. All right. So then we'll kind of have to, do a little bit more math here. So, and I'm going to bring this, oh, didn't mean to do that. I'm going to bring this down here just because it'll be easier to factor everything. So that's going to be 3 times, so this is 2x plus 5 times 2x plus 5, right? So 2x plus 5 times 2x plus 5, and then minus 7 times 2x plus 5 plus 2. So then if we distribute, that's going to be 3 times 4x squared plus 20x plus 25, and then I'm just going to distribute that 7 to those, so it's going to be minus 14x minus 35 plus 2, and then we can distribute that 3, right? So that's going to be 12x squared plus 60x plus 75 minus 14x minus 35 plus 2. All right, so then if we add all the like terms, let's see, we're going to get, and then I'm going to bring this back up to 44 part B, so kind of over here if you guys can see, that's going to be 12x squared plus 46x plus 42. That'll be our final answer. All right, so for number 45, it looks like we have two different functions, and we gotta take the compositions of them. So for part A, if we're doing s of t, let's see, so that's gonna be putting t inside of our s term, or our s function, right? So it's gonna be, let's see, 1 over x minus 10 minus 5. All right, so if we have to simplify that, it looks like we're gonna have to get a common denominator, right? So then we can just multiply by x minus 10, so that's gonna equal negative 5. So then we have to multiply this by x minus 10. So that's gonna be negative 5x plus 50 plus our 1, because we got that 1 right here, over x minus 10, which will give us negative 5x plus 51 over x minus 10, like that. So for part B, we have t of s of x. So now what we're doing is we're taking s and we're putting it into all of the x terms of our t function. And so it looks like we just have one x term right here. So that's going to be 1 over, and then we got our s function, x minus 5, and we still have this minus 10 tacked on the end. And so all we can do is just add the like terms of the negative 5 and the negative 10. So that's going to give us 1 over x minus 15.
Okay, so now for number 46, what we're going to be doing is taking this h of x function and splitting that into two different functions such that the composition is equal to h of x. So basically what we're kind of doing is finding an inside function and an outside function. So for here in h of x, I'm going to kind of notice I have two things going on here. First I have x minus 7, and I have something else that we're taking the cube root of. So what I'm going to do is I'm going to say my inside function, g of x, let's let that be x minus 7, and let's just say everything else, f of x, would be cube root of x. Now just to make sure that that f of g of x is equal to the original, what we would do here is say, okay, let's plug in g of x where x is an f, and that will just give us cube root of x minus 7. And that is indeed what we started with. So we are all good here. Now something that I think is important to note here is that there are definitely more than one solutions for each of these problems. So just because I have something and you have something different, you could still have the right answer, just you want a different way about solving it. And that's okay. That's okay. Moving on to part B, here we have on the inside 2x to the plus 5, and on the outside we have just everything being squared. So again, I'm going to say, okay, let my g of x be 2x plus 5. Then my f of x would be x squared. So let us try that now. So f of g of x is just going to be putting this 2x plus 5 in place of the x. So we're going to have 2x plus 5 squared. And again, that is exactly what we started with. So we are all good there. Now moving on to the last part, we have 4 over x minus 2 quantity cubed. So what I'm going to do here is I'm going to take that x minus 2 as my g of x. So g of x equals x minus 2. And everything left over is that 4 divided by our cube. So f of x is 4 over x cubed. Now to find f of g of x, just go ahead and plug this in for x, this in for x, and that would be 4 over x minus 2 quantity cubed. There we go. Okay, now moving on to number 47 here, we're given that at a popular website, the cost to download individual songs is $1.49 per song. In addition, a first-time visitor to the website has a one-time coupon for $1 off. So now we want to write a function to represent the cost C of x in dollars for a first-time visitor to purchase X songs. So based on what we're given, it is I would say it's pretty rational to assume that this is going to be a linear function, right? Because we're given that the cost is $1.49 per song, so that would kind of be like our slope. So I'm going to write C of x equals 1.49x. And first-time visitors get $1 off. So I'm going to go ahead and say minus 1, just because each song costs $1.49, and then the first-time visitor gets $1 off their whole order. So here, C of x equals 1.49x minus 1. Now moving on to B, we have the sales tax for online purchases depends on the location of the business and customer. If the sales tax rate on a purchase is 6%, write a function to represent the cost T of A for the first-time visitor who buys $A in songs. So now again, we are going to kind of assume it's going to be pretty linear, but here it's a little bit simpler just because we know that we're just adding 6% to whatever we purchase. So if we think about it as T of A, that is the cost with tax included, so it would just be our original cost plus 6% or 0.06 of the original cost. So here, T of A is going to be equal to 1.06 A. T of A equals 1.06 A. There we go. Now moving on to C, what we want is T of C of X. We want to interpret the meaning in context. So just go ahead and plug everything in. I have 1.06 times 1.49x minus 1. So going ahead and distributing this, we are going to end up with 1.5794x minus 1. So T of C of x is equal to that. Now, we need to interpret the meaning in context. So what this function here means, what we just evaluated, that is saying that for whatever the cost the first-time person is spending, we're getting out the after-tax cost. So we could say that this is the after-tax cost for first-time customers. Now moving on to D, we're actually going to evaluate T of C of 10. So that's going to look like T of C of 10, which is going to look like 1.5974 times 10 minus 1. And that is going to give us a value of $14.73, which means that for the first-time visitor, for first-time customers, 10 songs cost $14.73. Perfect. Okay, so the next problem has to do with the vertex form of a parabola. So what I'm going to go ahead and do is I'm just going to go ahead and give the equation of the vertex form of a parabola. So that looks like y equals a, x minus h squared plus k, with a vertex at h, comma k. All right, so now going to part A, we want to know whether the graph opens up or down. So what that, the main point that's going to be influenced by is here, that 2 in front. So because that 2 is positive, that means it's going to open up. Now we want to know the vertex. Looking back at the equation that we have x minus h, so this is the same as saying like minus -5 plus k. So we can say plus -8, which means that our vertex is going to be at -5, -8. Now for determining the y-intercept, that's just going to be when x is equal to 0, right? So that's going to look like, is we're going to say f of 0 looks like 2 times 0 plus 5 squared minus 8, which is the same as 2 times 25 minus 8, or 50 minus 8, or 42. So that y-intercept is going to be 0, 42. Moving on to the x-intercept, that is just going to be when y is equal to 0. So something that's interesting about parabolas is that we can have up to 2 intercepts, up to 2 x-intercepts, right? So what we're going to say is, okay, 0 is equal to 2x plus 5 squared minus 8. So I'm going to add 8 to the other side. To get 8 is equal to 2 times x plus 5 squared. Go ahead and divide everything by 2 to get rid of that one, which will leave that 4 is equal to x plus 5 squared. Now our x is kind of trapped inside of these parentheses. We have 5 being added to it. So to get it out of the parentheses, what we want to do is take the square root of both sides. Importantly, what that is going to end up doing is that is going to split into 2 different equations. We have x plus 5 is equal to the positive square root of 4, positive 2, and x plus 5 is equal to negative square root of 4, or negative 2. So subtracting 5 from each side, we get x is equal to -3, and x is equal to -7. So our 2 points are going to be -7, 0, and -3, 0. Perfect. Moving on to the next question, we want to know the minimum or maximum value of the function. So the minimum has to do with the vertex. We know that we're opening up, and we know that our vertex is here. So if we kind of want to sketch our function, that is going to look something like this, with our vertex there, which means that our vertex here is going to be the minimum value, right? And our value there is, again, -8. So here, we're going to have a minimum of -8. On to F, we want to know the axis of symmetry. Again, the axis of symmetry just has to do with the vertex. So coming back to our sketch here, our parabola is going to be symmetrical about our vertex. So here, this line, again, to get that, we have at x equals -5, just from our vertex. So the axis of symmetry here is just going to be x equals -5. Moving on to G, we want to know the domain of the function. Now the domain has to do with what inputs are legal for a function. So looking back at the function here, there's not really any point where that's going to break, right? Because we don't have any square roots that we're taking. We don't have any logs. We don't have any division happening. So no matter what value of x we plug in here, we could plug in 0, we could plug in 1,000,000, we could plug in 1,000,000,000. We will get a value out. So that means that our domain, again, is going to just be all real numbers, or from -infinity to +infinity. And then moving on, lastly, to the range. We already determined the minimum value of our function. Looking back at our sketch, there's not really a maximum that we're going to hit. So that means that we're going to hit the minimum at -8. There's not really a maximum happening in our function, because if we think about plugging in bigger and bigger and bigger and bigger values of x, what that's going to do is just let our function continue to grow. So it's never going to hit a point where it gets really big and just stops. So it's going to keep on going to infinity. Perfect.
All right, so for number 49, we are using completing the square to write these quadratic functions in vertex form, and then we're going to find the vertex, direction of opening of the graph, the min or max value, and then the domain and interval notation. All right, so if we take a look at part A, so we know that for vertex form, or for completing the square, we take the coefficient that's in front of our x term, right? So we take that, I'll just say 6, we divide it by 2, and we square it to get the value that we're going to be using to complete the square, right? So like if I have x squared, actually I'm not going to write it right here. It'll be our answer box. But if I have x squared plus 6x plus 5, and then our value that we're going to be adding to complete the square is going to be 6 over 2 squared. So that's just 3 squared, which is 9. So we're going to be adding 9, but we also have to be subtracting 9, right, to get them to kind of cancel out. And so then we can move this 9 over to where this looks like, this equation looks like x squared plus 6x plus 9, and then we'll have that plus 5 minus 9. So then, if we look at this whole little section, we see that this is going to be x plus 3 squared. And then we'll have that plus 5 minus 9. And if we do 5 minus 9, that's just going to be minus 4, right? So then we have our completed, or, our vertex, function in vertex form. So that's going to be equal to x plus 3 squared minus 4. Now, if we look at the vertex, that's easy, right? So that's just the negative of this. So it's going to be -3 and then -4. And I'll just say equals our vertex. And then since the coefficient in front of our, x plus 3 squared is positive, that means it's going to open up, right? So this opens up. So if it opens up, that means we must have a min, right? We're not going to have like an absolute max. We're going to have a min. And so our minimum value is, whenever x equals 0, right? So if we plug 0 in for this, we'll get just a min of -4 at the vertex, right? So min equals -4. And then our domain can be everything, right? So it can be from -infinity to infinity. And I'll just say domain. All right, so for part B, we're given the function -2x squared minus 10x plus 4. And I'm just going to scroll over here a little bit so we have a little bit more room. But the first thing we want to do is take this coefficient and take it out of both x terms, right? So if we do that, if we factor out a -2x, that's going to be -2 times x squared plus 5x. And then we're going to have, our completing the square terms right there, and then plus 4 on the outside, right? And so we can do a similar process that we did previously. We can take this leading term in front of the x term and say this is going to be 5/2 squared, which gives us 25/4. So then we're going to add a 25/4 here and then subtract a 25/4. Now we want to take this -25/4 out of there, because then if we keep that in here, we won't be able to complete the square, right? So if we try and bring that -25/4 out of there, what we have to do is, since it's being multiplied by this -2, we have to multiply it by the -2. And so then if we rewrite this is going to be -2 times x squared plus 5x plus 25/4. And then plus 4, and then plus a 50/4, right? And so then we can complete the square with this, right? Our squared are, we're going to have -2 times x plus, and then the term that goes in here is just this 5/2, right? So it's going to be x plus 5/2 squared plus, and then if we add these together, that's going to give us, I think, 33/2. Yep. So that's going to be our function. So I'm going to write that up here. Our simplified in vertex form is going to be -2 times x plus 5/2 squared plus 33/2. All right. So then that means our vertex is going to be at, I'll write it over here. Vertex is going to equal -5/2 and positive 33/2. And because there's a negative coefficient in front of this x squared plus 5/2, that means it's going to open down, right? So I'll say opens down. And since it opens down and has negative, it's going to have a max value instead, right? And so the max value will just be at that vertex. So max value equals just that wide point of the vertex. And then the domain will be for all real numbers, right? So -8 to, or sorry, -8, infinity to infinity. Jeez Louise. Okay, and I'll say domain. All right, so for part C, we're going to do a similar thing, right? And so I'm going to try and move to the left a little bit so I have more room. But we're given this function 3x squared minus 8x. So the first thing we do is factor that x squared coefficient out of both the x terms, right? So then we're going to have, and I'm just going to do it up here. So we're going to have 3 times x squared minus 8/3x, and then we'll have some completing the square terms, right? And so then we can work on completing the square and take this -8/3 and take it over 2, right? Gotta divide it by 2 and square it. So then that's going to be -4/3 squared, which gives 16, a positive 16 over 9. And so then we're going to have x squared minus 8 over 3x plus 16 over 9, and then minus 16 over 9. Now, we only want one of those constants within those parentheses, right? We want the positive one because it's going to be squared, so it has to be positive. So we're going to be taking this negative 16 over 9 out of the parentheses. But in order to take it out of the parentheses, we have to multiply it by this 3. So then we're going to get 3 times x squared minus 8 over 3x plus 16 over 9, and then minus, that looks like the 3 and the 9 can simplify to 16 over 3 instead of 16 over 9. So then we can work on completing the square, right? We know that, well, first, we know that the term is going to be negative, right? Because this x term is negative. So we're going to have 3 over x squared, and then we just take that number that we squared, that simplified number, that negative 4 over 3. So it's going to be also, it's not going to be x squared anymore, right? It's just going to be x, and then minus 4 over 3 squared, and then we'll have a minus 16 over 3 on, outside of the parentheses. And so that's going to be, if I come over here, come back over here, that's going to be our function. It's going to equal, I'll just say right here, it's going to equal 3 times x minus 4 over 3 squared minus 16 over 3. So now we know that the vertex is going to be a positive 4 over 3 and then negative 16 over 3, right? And because the leading term in front of that x minus 4/3 squared is positive, that means it's going to open up, right? So I'll say opens up, and because it opens up, it's going to have a min value, and that min value is just going to be at the vertex, right? So our min value is equal to that y coordinate, or y point of the vertex, which is negative 16 over 3. And then our domain is just going to be the same as always. It's going to be all real numbers, right? So it's going to be from negative infinity to infinity, and that's going to be equal to our domain. All right. All right, so for number 50, we're just doing the same thing as we did in 49, except it's a little bit simpler because we're only finding the vertex using vertex form. So for part A, we have this function x squared plus 6x plus 5. So if I write that like I'm going to complete this square, it's going to be x squared plus 6x, and then we got something else in there, and then plus 5. So then, if I find out the number, the constant that we're going to add in there, we're just going to take that leading x term, and we're going to say 6 over 2 squared, which just gives 9, right? So we're going to have a plus 9 in here, and then we'll have a minus 9 out here. And so then we can complete the square. We know that that's going to be x squared. Well, actually, sorry. If we complete the square, we know that this is going to be 3, right? This is going to be x plus 3 squared. And then if we combine these terms, that's going to be a minus 4. So that's our vertex form, our formula. And so we know the vertex is going to be at the negative of this, so negative 3 and negative 4. So I'll just say negative 3, negative 4. All right, so for part B, we're going to be doing a similar process, just a different function. And so since we have this negative 3 out in front of the x squared, we have to factor that out of both x terms, right? So then this is going to become negative 3 times x squared plus, it's going to be 3x, and then we're going to have another constant term in there that we don't know, and then plus 8 on the outside. And so then we can take this leading term in front of the x and say, okay, so this is going to be 3 over 2 squared, which, well, yeah, 3 over 2 squared, which equals 9 over 4, right? So we know we're going to have plus 9 over 4 out here. And then we know we're going to have a minus 9 over 4 within these parentheses, right? So I'll rewrite this so it's easier to see. But we know we're going to have a minus 9 over 4. Oh, goodness gracious. A minus 9 over 4 in these parentheses. So if we're going to take it out, then we have to multiply it by that negative 3, right? So then it's going to become, we're going to have negative 3 times x squared plus 3x plus 9 over 4, and then plus 8 plus 27 over 4. And so then we can go about completing the square. We know that we're going to have negative 3 times x, and then it's going to be plus this, just the term that this x term over 2 that we ended up squaring. So it's going to be plus 3 over 2 squared. And then we're going to have, okay, so if we combine the 8 and the 27 over 4, that's going to give us, I think, 59 over 4. And so now we have it in vertex form, and we can see that our vertex is going to be negative 3 over 2, and then that positive 59 over 4. All right, so for part C, it's a little bit trickier because we don't have, or a little bit simpler actually, because we don't have an x term. So I'll just show you, if we rewrite this with an x term, that's going to be like 6 times, and that's going to be like x squared plus 0x, right? And then we'll have minus 5. And so that's just going to kind of be equal to 6 times x plus 0 squared minus 5, right? So then if we kind of look at that, we'll see that our vertex is at 0 and negative 5. Negative 5. You can go through the whole process if you want to, just to verify. But since there is no x term, there really is no need to, because we know that everything is just going to be 0, right? So that kind of simplifies this vertex formula and the finding of our vertex. So, all right, so for number 51, if we scroll down here, and I'll move these kind of up here. Dang, these are never fun. Okay, so for number 51, if we come down here, we'll see that we have a rocket that is shot straight upward from ground level with an initial speed of 98 meters per second. Then this model represents the height of the rocket in meters, and then, after the launch. So it wants us to find when the rocket will reach its maximum height, and it wants us to find the maximum height. So if we think about this in graphical form, so we know it's a quadratic, right? We got this squared, we got this x term that's being, or I guess t term that's being squared, and then a negative coefficient. So if we just think about the negative coefficient and the fact that it's quadratic, we know that it's going to look like this, right? This is going to kind of be the behavior of the rocket. And it wants us to find when the rocket will reach its maximum height. So if we kind of look at this graph, where does it look like the maximum height is? Well, it looks like the maximum height is up here, right? And what does that also look like it is? Well, it looks like it's the vertex, right? And so in order to make this easier for ourselves, we can get this equation in vertex form, and then that'll give us the time when it equals the maximum height. That's going to be like our x term, and it'll also give us our maximum height, which will be the y term of that vertex. And so if we start rewriting this, we know that this is going to be, well, we got to take this out of both terms, right? So that's going to be negative 4.9 times t, and then it's going to be minus, and it's going to be minus because we are taking a negative 4.9 out, and this 98 is positive, right? So it's going to be t minus, and then looks like, I think we divide that out, it's going to be 20t, and then we'll have something in the square here, right? So then we can go about completing the square, and so we're going to take this negative 20, we're going to take it over 2, and we're going to square it, right? Which will just be negative 10 squared, right? So it's going to be 100. So we're going to have plus 100, and we're going to have a minus 100. All right? So, and remember, we just want to leave the positive constant in there since it's being squared. And so if we take this negative out, remember we got to multiply by this coefficient. So then we're going to have negative 4.9 t minus 20 t plus 100, and then plus 4,900, right? Or not 4,900, but my bad, just 490. Oh, goodness gracious. Let's try erasing that. Plus 490. And so then we can go about completing the square. We know that this is going to end up being negative 4.9 times t, and then since this is negative, we know that the 10 is going to have to be negative, right? And it's going to be 10 because it's always this term that goes in front of the x. So that's going to be minus 10 squared plus 490. And so this is going to be our function. But then we can take our vertex from that, right? We know our vertex is going to be, we know our vertex is going to be the negative of this, so it's just going to be positive 10, and then just taking this as it is, positive 490. So, and if we think about this, remember the x is time, and then the y is going to be height. So then when the rocket will reach its maximum height is going to be at 10 seconds, right? Or 10 seconds after it's launched. So I'll say 10 seconds after the rocket launch. And then the maximum height will be at 490, right? So the max height is at 490 meters. And that's our final answer.